Assalamualaikum everyone. In this video, my group and I will be presenting our task. These are my group members. From the left, we have Haris, and then to the right, me and myself, Nur Sabrina, and the last one, Sharifah Ruqayyah. This is for task 1, so let's move to next slide. We got question 9, which is under Haloalkanes topic. You may pause this video and try to answer all the questions given before checking the answers. The first one is about the synthesis of haloalkane from the alkene group. The starting material is 1/3 butyl cyclohexene. It undergoes hydrohalogenation with hydrogen bromide, producing A, which is 1-bromo 2/3 butyl cyclohexane following the Markov-Nikov's rule. Then, from 1-bromo 2/3 butyl cyclohexane, undergo hydrolysis with aqueous potassium hydroxide under reflux to form B, which is 2/3 butyl cyclohexanol. For the next chemical reaction, 1-bromo 2/3 butyl cyclohexane reacts with excess ammonia to form secondary amine, which is 2/3 butyl cyclohexanamine. Next, 1-bromo 2/3 butyl cyclohexane reacts with potassium cyanide in the presence of ethanol under reflux to produce 1-cyano 2/3 butyl cyclohexane. From the product of reaction before, 1-cyano 2/3 butyl cyclohexane undergo further reaction with lithium tetrahydroaluminate 3 ether and H3O+, producing 2/3 butyl cyclohexylmethanamine.
Next, 1-cyano 2/3 butyl cyclohexane undergo further reaction in the presence of H2SO4 and heat to produce 2/3 butyl cyclohexane carboxylic acid. Then, 1/3 butyl cyclohexane react rapidly with bromine in CCl4 at room temperature to form 1,2-dibromo 1/3 butyl cyclohexane, and we can see that the bromine atoms here attached at the carbon that has the double bonds before make the compound that is produced has single bond. Next, question asks to suggest a reagent and condition to produce compound A from suitable alkane. Give the structure of alkene used. So the reagent used is bromine and the condition is Hb, which represent the light energy, and the structure of alkene used is 1/3 butyl cyclohexane. Next, question asks to show the reaction mechanism if compound A undergoes SN1 reaction to produce compound B. So, we can see from the equation here, which is 1/3 butyl cyclohexane react with bromine in the presence of light to produce 2/3 butyl cyclohexanol. So the first step is formation of a carbocation, which can be known as well as rate determining step. So we can see here that C is delta positive, while Br is delta negative. So Br will attack the bond here because the Br is more electronegative. So Br will attack the bonding electron here towards itself. Then it will produce carbocation here plus with Br minus as anion. So we can see here that we use the double-headed curve arrow and the rate of reaction is low because we want to break the bond between Br and C. So for the step 2 is nucleophilic attack on the carbocation. First, we rewrite the carbocation that we got in the step 1. So, we can see the carbocation here react with nucleophile here, which is OH minus. So the OH minus will be attached to carbocation to produce 2,3-butyl cyclohexanol. So the nucleophile here, which is the OH minus, will be attacked by the carbocation because OH minus is rich with electron. And we can see here the rate of reaction here is fast for the step 2.
So let's continue with task 2, which is inequally components. The plant that we choose is pomegranate. And the ayat Quran relate to the pomegranate is from Surah Al-An'am, verse 141. And the verse goes, أعوذ بالله من الشيطان الرجيم وهو الذي أنشأ جنات معروشات وغير معروشات والنخل والزرع مختلفا أكله والزيتون والرمان متشابها وغير متشابه كلوا من ثمره إذا أثمر وآتوا حقه يوم حصاده ولا تسرفوا إنه لا يحب المسرفين. And the meaning of the verse is that, and he is who causes gardens to grow, both tree-lice and untreelized, and palm trees and crop of different kind of food, and olive and pomegranates, similar and dissimilars, each of its fruit when it yields, and give its due zakah on the day of its harvest, and it not be excessive. Indeed, he does not like those who commit excess. The component that we choose from pomegranate is punic acid. The IUPAC name for punic acid is octadeca 9,11,13 trienoic acid, and the functional group represented in punic acid is carboxylic acid. One of the components in the plant, which is pomegranate, is punic acid. Punic acid PA is a polysaturated fatty acid which is classified as a conjugated linolenic acid. PA is also referred as a super CLNA, whose effect is even more potent than that of an ordinary CLNA. It is found mainly in the seed of pomegranate fruit, Punica granatum. So what is the composition of the plant? Composition of the plant, the edible part of the pomegranate fruit, 15%, consists of 40% iris and 10% seeds. Iris contain 85% waters, 10% sugars, mainly fructose and glucose, and 1.5% pectins, organic acid such as ascorbic acid, citric acid, and malic acid, and bioactive compounds such as phenolics and flavonoids, principally anthocyanins. And next, the benefit of the selected component. The punic acid, it possesses a wide array of biological properties, including anti-diabetic, anti-obesity, anti-proliferative, and anti-carcinogenic activity against various forms of cancers. Lastly, chemical reaction. The chemical reaction is neutralization with a base. As we know that the functional group in punic acid is carboxylic acid, and carboxylic acid are acidic, so it will react with base to form carboxylate salt. So in this equation, we can see that punic acid, octadeca 9,11,13 trienoic acid react with base, which is magnesium oxide, to form metal carboxylate salt, which is magnesium octadeca 9,11,13 trienoate, and the byproduct is water. So that's all from me. Thank you.